and then we'll make a start. So morning everyone, hope everyone's getting on all right. I think it's kind of got into a little bit of the normal for me now, and being able to work from home and set the lessons and so on is starting to get a little bit more normal. So this one is another session looking at kind of teaching programming techniques and so on. We'll be using a little bit of the prim techniques that I use with my classes, so that you can go through. I'd recommend joining in and doing what you can as you go through. So if you've got Python on a device, if you get that open, then you'll get a little bit more out of the session. I think being able to see how it works for the students' point of view it can really help benefit you delivering it in this way, if you do choose to deliver it in this way. I really do believe it is a really good method for teaching it. So I won't go through everything on here, but I'm sure you've all seen the specification in terms of the programming techniques. So this is obviously what OCR is looking at. They've split it up into 2 different sections in the new specification. Exactly the same is still there, but it just splits it into kind of I think a programming fundamentals section and other programming techniques section now, but it's exactly the same. So you still got your obviously data structures in there, you've got your sequences and your constructs and so on, looking at string manipulation and file handling, and SQL and all those sorts of things. It's all still in there. And so this is kind of the next stage on after I've introduced Python for the first time, where they've just in the first lesson they'll just look at things like prints. I then go into doing some inputs, which is what we'll look at today, and how I go about teaching some of those bits. So hopefully you'll see kind of my methods for it. I will kind of go over this. I did talk about this slide last week as well, but this one is I think a really useful one when it comes to writing the algorithms for the exams. I think I know I teach in Python, and we don't really mention writing algorithms for exams up until kind of they really start working towards them towards the end of year 10 and start of year 11. So they'll be writing exclusively in Python a lot of the time, and we will kind of introduce kind of other ways of writing algorithms, but most of the time they're just going to be writing in Python, and it is fine for them to write in their chosen language, and it will be fine for the new exam as well. But what I do try and encourage when they do start to write for the exams is that the function names go into capital letters, just to differentiate a little bit from the language that they write in. I think it just helps to make it really stand out, especially for the examiners. I think when it comes to reading the exam answers, especially those where their writing is a little bit untidy, it's really easy to be able to see the functions when they've been written in capitals each time, and then it helps to clear anything up, hopefully. Excuse the dog in the background, sorry about that. If there's anything else they need to do, so any other functions and things like that, they can kind of really make up their own function names for things they might need to do, as long as they're descriptive. So if they're using things like they need to find the maximum value of something, if they create a function called max, then most programmers will understand what that means. And I think using comments is another thing. Even if the question's not specifically asking for it, I think there's nothing wrong with them always writing comments, and I try and get them into the habit of always writing comments with any algorithms they write, because again, that can help with the exams. If it's a little bit kind of unclear what they're trying to do, if there's a comment next to it that says this is supposed to do this, then that could be the difference between them getting the mark and not getting the mark. So really useful to go through. So I will quickly go through Prim. I don't know if everyone has seen this before. If you've been to the meetings, I'm sure you have seen it, but it's just a structure to teaching to program. And I find it really useful. It really helps to focus the students and get them working, especially kind of in this lockdown period, because they just have these prim tasks that they can carry on working through. And a lot of it is very self-led once they start to use prim, because it's really easy to be able to work through. They may struggle with the make tasks sometimes, but if you kind of scaffold it a little bit, and I'll talk about that, how you might do that a little bit later on. But they have some code to begin with that you get them to predict what you think it's going to do. Sorry, so I'm trying to say something. No. So having that code initially, they can go through and read it line by line if they need to, and even explain line by line what does the first line do. Ideally, it's kind of a technique that they've already seen before, whether they've programmed with it or whether you've just introduced it in that lesson. So you might do kind of 5 minutes before, talking about what print does. And then once they know what print does, they can then start going through these tasks. And once they've had a go at writing down what they think the code is going to do, then they can go on and they can start to run the program. And then obviously they'll see whether they're right or wrong. Investigate should be a stage where they're looking to develop it a little bit more and think about what's actually going on. So asking them questions that they need to answer. Think about what you want them to get out of it, what you want them to understand at the end of the time. And those questions, I think, are probably the most important part of it. Then the modify can be changing the code in some way. So just give them a task that they need to do, whether it's slightly changing the code to do a different thing, or maybe the initial program you gave them was incorrect. And so you're just getting them to modify it so it now works. Anything along those lines. And obviously, last week I talked about how this really ties in with the OCR specification in terms of they need to be able to identify what programs are doing. They need to be able to fix errors and identify those errors and those sorts of things, and kind of Prim really ties in with that. And then the make part is where they'll have a new program that uses those same techniques, or even techniques that they've used in the past, things that they're familiar with, that they can then try and create a solution for. Those of you that have downloaded my resources from CAS will have hopefully seen this, and this is kind of the structure that we've got set up so that it works, and they'll have 3 or 4 of these activities for each technique that we're looking to go through. There may be that we do a couple of lessons on one particular technique because it's one that takes a little bit longer, but they'll have kind of, for every lesson that we do, 3 or 4 of these they can then go through. And so you can see that we've structured it so that they can always work through it and follow those different steps. And obviously you can see from here that some of the investigate questions are just things like getting them to notice what the code looks like, so they get to grips with the fact that editors will change colors to make it clear that they've written a function correctly, and those sorts of things. But then there are some that it's just, okay, so what does this do? Make sure that you can explain what this function is for. The modify, so if you do need to scaffold it a little bit more, I tend to just bullet point some instructions in English of what they need to do, just to make it a little bit easier for them, and then they just have to turn it into Python code for those that are struggling. And I tend to do it in kind of 3 stages. So this one would be given to all the high ability students that don't need any help at all. For the middle ability, I'd just have some bullet points on the make task, and I'd expect them to be able to do the modify task without any help at all. And then the low ability would also have some comments for the modify, just to help them out with that. And I also change it a little bit that all the make tasks come at the very end of the section. So they only do up to modify 3 or 4 times. And once they've done all of those, they can have a go at the make tasks later on. So hopefully that kind of makes sense with Prim. I don't know if anyone's got any questions regarding using Prim at all. But now just going to have a go at hopefully you doing a little bit of coding and using Prim. So I tend to not guide them through so much. A lot of the time they're going to be doing it kind of on their own, but obviously initially they do need that little bit of guidance on how it works. So for the first 2 or 3, I might say, right, you need to go through and you need to predict now. And I just give them all a couple of minutes to predict what they think the code might do. And so hopefully, obviously, this one would be looking at using the input function. So I'd start with a little bit of an introduction of, so the input allows the user to type in some responses to questions or prompts that are given to them, and that I'd let them know that the prompt goes in between the brackets. It needs to go in speech marks because it's a string, and I'd also introduce variables so that they can then store that input. And so we talk about the fact that we've got a variable, and we talk about the rules of variables, how they can only have kind of one word, if you like, and they're not allowed any spaces in. They're not allowed to have symbols in. I tend to say no symbols at all. I know you can use underscore. I tend to just say no symbols because I find it a little bit easier for them to say no rather than saying no symbols other than underscore. If you just ban them at all completely, I think my students tend to find it a little bit easier. The fact they can't have numbers at the beginning of them as well. All those kind of rules that you make sure that you go through, and obviously the added one that's not really set in stone but is useful to start to talk about naming conventions, the fact that they should be sensibly named so they describe what they're storing. So hopefully you've had a little bit of a look and you can have a think about what you think this program might do. I'll give you another 30 seconds or so if you haven't had a chance to read through it. And so it's literally at this stage about the students thinking about what they think. There's no kind of right or wrong answers. I don't mark predictions at all. I'll have a look at them, but I won't really pay much attention to them at all. This is really just for the students to start to get their head around reading the code, because I think there isn't a huge difference really between learning to read and write English as such and learning to read and write code. You tend to learn to read it before you then start to write it, and I think it makes sense to do the same sort of thing with programming as well. So then obviously the next bit is they then have to copy the code. There's a couple of ways that you can get them to do this, and by all means feel free to have a go at creating a program. Like I said, I think it tends to work a little bit better if you do join in as you're going through. I tend to make them type it out because I think getting them used to typing the code as much as possible, especially the lower ability students, it does obviously take them longer to do the typing, and so they do tend to go at a slightly slower pace because of it. But I think there's a huge amount of benefits to them actually being able to write it and get used to writing the code and just copying it out, because they'll make mistakes even when they're copying, and if they can just start to use that, and they can then start to use the mistakes that they're making later on, and hopefully they'll have seen those mistakes, so they may miss out a bracket, but because they're copying it, they'll be able to, when it does give an error, they'll be able to compare their code to some code that's given to them before, which in most cases will work. Obviously, sometimes you might put a deliberate error in there, and obviously in that case, they'll type it in right, and there will still be an error. It's probably worth letting the students know when you do put programs in there that have got errors in there if you're doing it this way, just so that they know that they're not causing any issues with the program and it's what it's supposed to do. And so obviously once they've had a go at reading through and then obviously copying this code out, they can then have it run, and they'll be able to see whether they were right or wrong. I don't know whether many of you have had a go at predicting what you think it might do. What did the program actually do? Anyone brave enough to go?
It prints out the colour that the user inputs.
Yep.
And then with the string is my favourite colour too. So if the user inputs pink, it would say pink is my favourite colour too.
Excellent. And so obviously this is kind of getting them into to think about what's going on. So then the questions that I would have kind of lined up, these are the kinds of questions that I gave my students with it. So firstly, what is the equals there for? So what does that mean? And trying to get them away from the fact that it means equals, because I think if they're using that, obviously when we start to look at selection later on, they tend to get a little bit confused. So I always will say it just means assign, so or assigns to, and so you can then talk about how the symbols are used in there, and obviously we've got this variable that's going through there. A little bit of a kind of modified part within this investigate as well, where I'm getting them to change the line 2 bit to put colour inside speech marks, so they can then see what might happen. And obviously they should hopefully see there is a difference. And obviously this can then link back to data types and talking about the fact that if you put the word colour in speech marks, it's no longer the variable colour, it's just the string colour, which will then just be displayed as it is. And obviously that will link back to what they were doing in the previous part where we introduced kind of printing and using strings and numbers and so on. And then again, I get them to do a little bit of a change in there as well, where they're changing the spelling of colour. So maybe they change it to the American spelling for the second line, but not for the first line. And hopefully they will then see that there is an error. And it's kind of an opportunity to then talk about the type of error, so they can get a description of that. And we have an error log that the students have to fill out as they go through. And so
I'm a teacher, so just bear with me. Hold on. Let's just mute this for a minute.
So the error log is there for them to record any errors that they find, and that includes the ones that I create for them. And by doing this, hopefully they'll see that they've got a naming error. They'll see what it means, and obviously they'll know what they did to cause that error, because obviously they've just changed it. And so they can then talk about how that then gets fixed later on. So if they see that same error message again, they should hopefully be in the position that they can fix it without the need for the teacher to come in and support them. See, that's the plan. Doesn't necessarily work, but I think the students that use their error log really well are the ones that do tend to advance a lot faster, I've found.
Do you give them sorry, Martin, do you give them an online, online error log, or do you
yes, so it's part of the OneNote package that we give them. So we just send them out. It's really just a table that is added into their page. And so all that has on there is a table that's, I think it's got 4 columns in there, a screenshot of what the error message was, a description of what the error is, and a description how they fixed it and the date they found the error. Just to keep a record.
That's quite a lot of writing, isn't it, for the weaker students? That's
it's not a huge amount.
Okay.
In most cases, most of the students will only write 1 or 2 lines.
Yeah.
And it's just about getting them to think about what it is that's caused it. I mean, there's nothing to stop you having a more fancy one, maybe where they have a drop down box that they choose, and just to help to go through that. And potentially that might work a little bit better for some of the lower ability ones. But I think the lower ability ones especially, I think they've got a lot more to gain from keeping an error log. And if it takes them a little bit longer to go through the process of learning, I think it will only help them. I think I mentioned last week, I think it was, that we have kind of some more advanced tasks later on. So at set points within the program, if you've seen on my work on CAS, we'll have just a set of make tasks that the students that have really gone ahead will then kind of sit and do, and those are really only there to give them some extra work while the others then start to catch up. And get to a certain point that they can then move on to the next techniques that we need to look at. And kind of that's kind of what we've done to build it in. So it's designed in a really flexible way that once the students will finish one technique, they'll then move on to the next technique. But if the students, the weaker students, which there will always be in there, haven't finished that first technique, they're going to carry on with that technique that they haven't finished yet. And so some of my weaker ones took 2 or 3 lessons to go through just learning about print. And then obviously by that time, some of the more advanced ones had already gone through inputs and were then starting to look at using selection, I think it was. And I think it does make the kind of the managing of it a little bit more difficult in terms of thinking about what's going on and trying to make sure that you help. But at the same time, I think it really benefits the lower ability ones to go through at their pace, and also the high ability ones to be able to go through at their pace. And I think it has worked in terms of the students we've got that since we've been doing it this way have got a much better understanding of the basics than when in the past we may have just moved them on a little bit too quickly and they hadn't quite got to grips with the basics of it.
Yeah, definitely.
So, and then obviously there's another couple of questions in here that where you're talking about in terms of this case, what does the plus do? Obviously they've seen the plus used with numbers, but now we're using it with text and we can talk about it. We don't go into too much detail about what it actually means. I tend to save that for when we do move on to the string manipulation, and that's when I'd start to introduce concatenation and that sort of thing. But they've seen it at this point and they can start to think about what's going on. But I also get them to think about the difference between the plus and the comma, and how you can use both in some situations, but in other situations you can't. And what that actually means and how it's different to each other. And so this would be the modify task that I gave for them. So by all means, feel free to have a go at modifying your program if you've started to write it. And so this one is just asked for their favourite subject. Obviously, ideally, but not looking just to change the messages, and hopefully the students realise to change the variable name as well. And obviously that's where you really start to understand which ones have understood what variables are and what they mean, and which ones don't necessarily understand too much. But like I said, for the lower ability ones, you can then give them some step-by-step instructions on what they need to change. So you might say, right, change the variable name to subject, change the messages that's inside the brackets, and so on, just to give them a little bit of guidance. Obviously, you're not writing the code for them. They've still got to go through and think about the code that needs to go along with it. But it's just giving them those pointers to help them out with it a little bit more than the ones that can do it all on their own. And then you've got the make task. And so again, this is fairly similar. This time we've got 2 variables that are needed and 2 different inputs, so it's a little bit more complicated, but it's still using exactly the same techniques. So getting the program to ask the user for the first name, ask for a second name, and then print the names joined together with a space in the middle. So I shall give you a few minutes to have a go at doing that one. And if you've got any issues, then I'm more than happy to help out with anything. Or if you've got any questions about anything I've spoken about so far, then again, just feel free to ask. How is everyone getting on with that? What methods for joining could you use within it?
What year were you? You were starting with year 9, weren't you, Mark?
Yeah, so this is the year, the beginning of our year 9 scheme, which is quite nice. It won't be too much longer that we've got that luxury.
Can I show you my screen?
Does it let you share your screen?
Yeah.
Then you're more than welcome to.
So this is what I would have done. So I'm using Mu. Can you see it?
Just bear with me. I've just got to find my Teams. But yeah, got it.
So I've put in that. That's what you did. And then so I thought for an extension class, an extension task, I would get them to put it on a new line.
Yeah.
And then things like a little bit of formatting, like putting a space in so that it comes out properly, nicely laid out.
Yeah.
And again here, adding a new line. So where you said change it, I thought that would it be better that they add it in, so they make their own, so that they've still got the code there, then they add it in. But then the next thing to do for the modified task is to go back to what you said at the beginning to do make sure they comment their code. So in here now, say okay, fine, and then go in, and then the next task, or maybe a homework task, is to go in and comment all lines.
Yeah. Yep. I think anything along those lines, I think is, I'm by no means saying that my way is the best way to go about doing it. And hopefully it's something that you can kind of tweak and improve, and I think work for your students and what they need to go through. I think, yeah, getting them to do the comments and those sorts of things. I tend to leave commenting out for a little bit. I just get them to kind of focus on just doing a little bit of code to begin with, just because going through too much at the beginning with some of my students does make them a little bit overwhelmed. So I tend to leave the kind of the commenting side of things out till a little bit later on. But there's nothing to stop you. You're starting to do that a little bit earlier on, and obviously whatever works with your students and what you're doing. I think that's the main thing at the end of the day, isn't it?
Thank you.
No problem. Has anyone else got anything they'd like to talk about in terms of the coding styles and things like that? No. So this would be the next one of the next tasks that I do. So it's a similar sort of thing. So again, this would be the one, I think the second or third one that I gave them for looking at input and getting them to think about what's going on each time, and again getting them to kind of trace through line by line, thinking about what's going to happen, obviously writing down their answers. And like I said before, it's not about thinking about the code and what they think being correct. It's just about getting them to think about what they think it means, and hopefully they are starting to get to the grips with what the input is doing and what the variables are doing by now, that they do get it right. But even if they do get it wrong, it's not the end of the world. And then obviously they can go through and they can have a go at running the program to see if they're right. And I'll give you a couple of minutes just to type that out to see what happens if you're not too sure already. I'm sure there's people that have worked out what might happen by now.
Does it not do any addition because you haven't declared it as an integer?
Yep. So this is one of my nice deliberate errors that I give to the students, putting them in there because they can't do the addition of an integer or any number to a string. And obviously this is where I can then start to talk about the fact that by default all inputs are a string in Python. And so if they then want to try and change that, obviously in the investigate side of things, this is where I'm getting them to think about what's going on. I get them to use the stepping through the program as they go through, so they can see, because they won't necessarily know straight away what's going on. Getting them to think about what is displayed, and obviously they should think about the fact that it's an error message that is being displayed. Actually getting them to think about the data types in there for that input function, like I mentioned. And then I get them to think about what might go through and fix this error. And they won't have been taught about the int function at this point. But what I want them to do is to just think about what that next step might be. And this is where I would then start to get them to think about what they could do instead. So the modify part, I get them to think about what they can actually do with it. And so I get them to think about trying to square the number instead of multiplying it by 10. Not going into the int function, because I don't want them to necessarily use that to begin with, so they don't actually fix that previous problem, but they should see that they get similar error messages if they're trying to square it by multiplying it by itself. Obviously they won't be able to multiply the string by itself, and hopefully that will then kind of get them to think about the problems that are caused with strings and trying to do maths with strings, and it tends to get them to really understand that the string and the numbers are completely different when they're trying to go through and do that. And then the next part that I then get them to have a go at doing is this make, where I get them to add them together. Again, I still haven't talked to them about using the int function, but they can then have a go at doing the mean, sorry, the total, and see what happens, and also the mean and see what happens with that one. And see the total in this case will have just the two numbers side by side, and then the mean, again, that's going to have an error message, and again, that's just kind of really cementing in the fact that these strings, they need to be introduced introduced as a number, so using the int function or the float function to convert them either into an integer or into a decimal number if they need to do any sort of maths with them. And then the next task I tend to do as.
Do you have the program for this here, the Python, so I could see what this Python looks like?
I haven't, but I can very quickly put it out there. Can you see that at my Python editor at all? Has it shown it for you?
No, I can still see the PowerPoint.
It's because I shared the PowerPoint instead of my screen. Is that better?
Yep.
Brilliant. So if I was to do this, I'd have my first number. I'm not going to bother with the prompts for it, just to save a little bit of time. And so obviously for the total, I would probably just get them to print N1 and N2, and then obviously for the mean, I'd probably expect something along the lines of some of the more advanced ones would probably start to introduce variables for the total, thinking if I'm going to use it twice that I can have it as a variable and then reuse it.
Yeah.
But anything on those lines, I think, is just about them having something. So just something on those lines is all I'd expect to see for that program.
But then this wouldn't work, would it?
No. So if I run this one, because we haven't introduced the int function, it won't do anything. So. So I see we get 23 or 23, and then we get an error message. What I would then do is my next activity, so the one directly after this one, I would get them to do exactly the same thing. I have the same program, so this same program here, but I've converted the input into an integer. And so what they'll then do is go through exactly the same prim activity, really. So where this program is exactly the same, but the only difference is that we're now using the int function. There'll be some questions, obviously, related to the fact that this now works. Why do you think it's now working? So hopefully they can link that to the previous activity. And they'll then see that the number obviously will add 10 onto the number that was given to it. The modify would be exactly the same. So they'll then be able to see what happens when they do actually square it when they are numbers. And then the make one would be exactly the same as well. And so then obviously this second one would have one where there's error messages in it because it's just not working, and obviously they'll see those errors, they can add them to their error log, and you can talk to them about these errors. And then the next one where it is all working, and they can kind of really clearly see that the int function is the bit, or the float function, depending on which one they decide to use, is what's allowing it to now happen. Does that make sense?
Yes, maybe.
So I think it may seem like a little bit of a backwards way of doing it, but I think for a lot of the kids, I think seeing it not working and then working helps them. Has anyone else got any questions about that at all?
Yeah, hang on, I do.
Yeah, that's no problem.
Hang on, I've totally messed this up. Wait. Can you see that?
Yep.
Okay, so what have I done wrong?
So with the int function, it's the other way around. So the int has to go around the input. So you're converting the input into it if you're using it in that way. So it's int, open brackets, input, and then obviously both sets of brackets, and remember to close the int brackets as well.
I really hope this isn't annoying anyone else.
Not at all.
I think it's probably quite useful to see what other people in what other people are seeing and how they're kind of picturing it as well. I think the more examples you can see what's going on, the better.
Don't forget to add it to your error log.
Exactly.
It's either this or curriculum planning.
Yeah. Oh, well, I've got that in a couple of weeks.
Yeah, we've had the rundown of our SMTs managing to find ways to fill our time now, aren't they?
Well, I am doing a curriculum planning meeting later on. I don't know if you've seen my messages on Facebook.
There you go. Okay.
Oh my goodness, I've got to go. There's so much now on Facebook in the CAS thing, isn't there? Has someone worked out a schedule? Could really do with a schedule.
Yeah, I know. It's
I think a bit overwhelming going through it. So I don't know if someone at CAS wants to do like a weekly what's happening. That would be
it might be a good idea. I might raise it.
And also, I saw the Isaac stuff as well. Which Isaac.
Yeah.
And that's really frustrating because it's all booked up and it just seems to have come up in a blink.
Yeah.
And I want to get some of my students onto that, but I think it's all full now. So by the time, because I don't work Thursdays, I think by the time it came out on Thursday, it was all booked. But there you go. So a schedule will be great from someone at CAS if you can give that feedback.
I'll talk to my outreach manager and see.
That was fab.
Tim is doing something quite good because he is getting them done all as invitations, which means that when you then sign up for them, you've got your own calendar of what you've signed up for.
I had a whole load of invitations this morning. I thought, what? All these events I'm supposed to be going to.
Yeah.
I saw that. That's at least that makes you know it's happening.
Yeah. So, no, I'll talk to them when I think I've got a meeting scheduled with my manager soon, so I'll raise it and see.
Really useful because I wanted to point my staff doing year 10 to this for next year to the PRIM method. So if we've got those things, we can coordinate a little bit with our staff as well, so that people aren't all doing. Well, I mean, obviously, I'm happy for them to choose. It'd be nice if we did things that are relevant to what we've got.
How is that? Why is that wrong?
Maths. Big maths.
Oh yeah.
So do I need to do? Do I need to put a bracket here?
Yeah.
First.
So you'll need to open another set before N1 as well on line 10. Yeah, so on there. So then you do the N1 plus N2 first, and then obviously divide all of that by 2.
It's interesting watching Mew work. It's nice, isn't it?
Yeah.
I could definitely see this for like Key Stage 3.
Yeah, it's quite a nice one actually.
And it's nice to see it used.
Yeah.
Okay, I shall stop that now.
So that's all right.
Martin, thank you. That's really useful.
So yeah, so obviously that's obviously that part. Then once that's done, I then move on to starting to do some selection and looking at using if statements in there. And so obviously this is a new technique. So again, I'd spend kind of 5 minutes or so going through kind of what the if statement looks like. I'll give them an example. So on a slide, I'll just give them an example of what it might look like. Obviously they've got the input in there again, and so they're still using obviously the previous techniques, and obviously hopefully getting used to those. We'll talk about comparison operators and how obviously they work, and obviously we've now got the double equal sign instead of just a single, and obviously that's why I try and get them to talk about the single equals being assigning rather than equal to, and then obviously we've got the double equals, which does mean equal to, but obviously we then talk about the greater than and less than signs and so on that they can use as well if they need to. Obviously within here then there's a couple of key bits that I would explain. That we've got a condition that goes after the keyword if, and that has to have values either side of an operator, and I'd be clarifying and kind of re-emphasizing the data types here, how in most cases that it's a variable that goes on the left, and obviously making sure that they remember that variables don't have speech marks, because that's one of the things that I think they do tend to forget about. And then a value on the right hand side, and if it's a text value on the right hand side, then that would need to have speech marks. So in this case we've got the number equals 6, and then it's just printing that is correct, hopefully. But has anyone worked out what it would actually do?
It would ask for the user for an input, and the user will put in any number, and if the number that the user puts in is 6, then it will say print, it will print out that's correct. Yep. But I'm not quite sure what would happen, because the if statement seems to be open and nothing else is happening. But I don't know what would happen if they said 15. What would happen then?
So with that, it just carries on with the rest of the program. So the if statement can have no other parts to it. So it can just have an if. It doesn't have to have an else. It can just carry on with the rest of the program. And so if there was some more code later on, then it wouldn't do anything apart from just skip through lines 3 and 4. This program, for anyone that has noticed, would actually just skip past lines 3 and 4 without you noticing, for the reasons that we were looking at earlier, the lack of the int function. So we've got number equals the number 6, but number would be storing, even if they did type in 6, the string 6. So again, this is an opportunity for me to talk about the fact you can't compare strings to numbers, and the investigate side of this goes through this. So looking at logical errors now, and making sure that they understand what we mean by a logical error, how the program is working, that it's all running, but the output isn't what we expect to happen. In fact, there's no output at all because we haven't got an else option in this case, so that nothing happens even though something should happen. And so this bit is something that we can talk about, and those logical errors can also be things that go into their error log as well.
So does that mean that at the minute, if when it says put in a number is equal to input, guess what number I'm thinking of? If they put 250, it would look at that 250 as a string.
Yep, so it would just be, in terms of Python understanding it, it will just understand that there's 3 characters there, 2, 5 and 0.
But then if they did perchance put in 6, would it compare 2 characters?
So it would be comparing the string 6. So the number 6 would be treated as a string, and the number 6. And those are completely different in terms of Python's eyes.
So I don't understand why. Why would line 3 not be looked at as a string?
So line 3 is not looked at as a string because the word number would be a string, okay, but the 6 is just the number 6.
Why?
Because there's no speech marks around it.
Ah.
So if you go through, so you could solve it in a couple of ways. If you can just bear with me a second, I'll just better answer that.
I love it. You're posty.
Sorry about that. Dog goes crazy. Yeah, so with that, the number 6 is treated differently. So what I can do, and this is something that I do to go improve it. So I can go in and have the string 6, which is what is being stored in that variable number, equals 6. And then when I run this program, what I'll have is false. And so obviously that'll mean that the answer is
Can you
not true.
maximize your screen, please?
Of course I can. I'll tell you what, I'll make the font is probably better to go bigger.
Should I shoot this plan?
Yeah.
Huh?
Yeah.
Here's this plan.
Is that better?
You can make it bigger if you like.
Bigger, even good.
Yep.
Is that better?
Yeah, thank you.
Yeah, so all I've done there is I've just put my comparison, which is what would be evaluated by Python inside a print. So you can see what gets returned as a result of it. And so the bit in the number, the bit in the number variable is the string. And obviously the bit that we've given it to compare it against is a number. And so those are completely different values. So there's 2 ways that I could go about solving it. So I can either convert my number, sort of my variable, into the string, and so that should then return true. Or I could have a string on the other side.
But the first way that you did it, wouldn't you have to have taken away the bracket, the quotation marks when you did the int?
No, so because what I'm looking at, so if I do it this way, okay, what I have to do is I need to give the integer function a string to begin with. So I'm just saying, right, I want you to turn this string 6 into an integer. And so when I do run this, I don't know why this isn't there we go. So when I do run this, I'm just going to clear that so you can see that one returns true. Does that make sense?
Has the answer been true? Is that what will come up?
Yeah, so that's what gets returned, and that's how the if statement works. It works on the result of the comparison being true or false. And so when we run these, and so that's why I've used the print function, so I can just go through and I can show you what gets returned. If I go
6, no, sorry, can you put that back, leave it at print, and change the 6 in the brackets to 7?
Yeah.
And then run it again. Ah, that's exciting.
So, and then obviously what that then means is we can then just introduce the if part in there that says, I'm just going. That is correct, or whatever it is. And so now I've then got that. So this is my number variable, if you like. I'm just using it here, so I can then run it, nothing happens. But if I then go through and change that to 6, then something should happen. And that's obviously because of what's being returned. And obviously you can talk about that and you can show that to the students in terms of what we're looking at is basically saying if true. If true, then run this line of code. So I can actually change this to true, and in theory, hopefully, it should work. And so it's just looking at, does the bit after if, or is the bit after if true or false? If it's true, then obviously that's what we're going to do. If it's false, we're going to do something else. In this case, there isn't anything else. It will then just be looking at just running the rest of the program.
Thank you.
No problems. Anyone else got any questions or anything relating to that?
I'm good, thank you.
So yeah, so then the next part is to have a modify bit. So this is where I'm getting them to identify how they fix it, obviously like we were just doing. And then the make part, I just get them to do a quiz question that just says if they're right or wrong, or sorry, just right in this case. And then later on we look up other bits in as well. But I think that's kind of puts us around about 11 o'clock. So I know some of you may have got other bits and pieces to do. What I'll look at next week is going on with some more if statements and hopefully showing you a little bit of that and look at a little bit of iteration as well. Has anyone got any other questions or anything else they'd like to clarify?
Did you go through your whole PowerPoint?
There is one more set of tasks, but I'll add that into next week. It's just another if statement on there, which is this one. So this is just getting them to do it in a little bit, introducing the elif side of things.
Okay.
Like I said, I'll add that to next week's, and we can go through that next week in a little bit more detail.
Okay. Thank you very much. Yep.
Is that
brilliant.
useful?
Yeah.
So I never know whether doing it like this is useful or not, but hopefully you do find it of use. So, like I said, I have got other meetings and bits coming up as well. And next week, I'm thinking Tuesday because I've got to be at school on Monday. So I've got my next day doing the babysitting job. If that is all right with everyone.
Yep.
Yeah.
So, but I'll put it on Facebook as normal. I'll advertise my other ones. Like I said, I've got a curriculum planning meeting coming up as well, where I can look at kind of Key Stage 3, Key Stage 4 curriculums if anyone's interested in attending that. It's one of the official CAS meetings that I'm putting together. So I did put a link onto it a little while ago. I think mid last week, but I'll have a reboot of it later on as well.
Thank you very much.
Not a problem.
Okay, bye.
Bye.
Martin,
Yes.